Welcome to Math 1324, Section 5.2. In question 1, we have a series of inequalities or conditions. They're going to give us a point in the plane, 5, 8, and the question is, does that point satisfy all of these conditions? Well, you simply let x be 5, y be 8, and plug them into each one and see if it gives you a true statement. So for the first one, yes. The second one, yes. The third one, yes. And yes, 5 is greater than or equal to 0, and 8 greater than or equal to 0. These last two conditions are going to appear very often. And all that says is that we are dealing with points that live in quadrant 1. So all it's really telling me are points that live here in quadrant 1, these last two conditions. In question 2, we have a graph over here, two lines and different shaded regions. And if you look on the left, we have 9, 10, 11, and 12. They are all exactly the same. The only difference is the direction that the inequality is pointing, whether it's greater than or equal to or less than or equal to. So they want us to figure out which shaded region goes with which condition. So I picked a test value, just like we did in the first problem. So I picked 4, 0, and I plugged it in. I plugged it in because y equals 0 makes things easy to calculate. So I have a 4, and 4 is less than or equal to 16. 7 times 4 is 28, and that is greater than or equal to 0. So where do I have less than on the first and greater than? Less than, greater than, that's number 9. I then went up to the yellow region and I see that they're counting by twos, so this would be 8, 10. So I plugged in 8 and 10, so I've got 8 and 2 times 10 is 20. So I'd have a 28, and that is bigger than 16. 7 times 8 is 56 minus 20, and yes, that's bigger than or equal to 0. And so where do I get something bigger on both? Well, that's number 11. And then I went to the purple region. Let's see, again by 2's, so this is minus 4, 0. So I plug in minus 4 and 0. Minus 4 is smaller than 16. 7 times 4 is minus 28. That is less than 0, so they are both less than. And where do I get both less than? That's number 12. And then the only one left is region 2, which goes with condition 10. All right, in question 3, they're going to give us two lines, and they want us to graph the things that solve both of these inequalities. So the secret is, first, we need to know what does each line look like. And the easiest way to do this is to grab the x and y intercepts. So set x to 0. I have minus 4y is minus 8, so y is 2. If y is 0, x is minus 8. So 0, 2, minus 8, 0. All right, so let's see, where are we at? Minus 8, 0. We've got 0, 2, so this is line 1. It is a solid line because of the inequality. And the other line, let's see, if x is 0, y is 6. And if y is 0, x has got to be 3. So 3, 0, 0, 6, solid line because of the inequality. So that divides up the plane into 4 regions. The question is, which one works? So I pick a test value of 0, 0. Is 0 bigger than minus 8? Yes. Is 0 less than or equal to 6? Yes. So this whole region works, so you shade it in by using the little pouring tool, like you're pouring a bucket of water. All right, in question 4, they want us to know, is the solution bounded or unbounded? Well, bounded means it's covered on all the sides. Unbounded is there is a region that extends off to infinity. So let's see. The last two parts here say it's in quadrant 1. So here's quadrant 1. I have my line. I need to know, what does it look like? All right, so if x is 0, y is 40. If y is 0, x is 2 times 20 is 40. All right, so I've plotted my line, solid line, and now I'm trying to figure out which part is going to work here in quadrant 1. Is it the stuff in here, or is it the stuff out there? So I picked a test point. I picked 1, 1. So is 20 times 1 plus 1 less than or equal to 40? Yes. And so the region is everything inside of here. It is a closed-in region, therefore it is bounded. In question 5, we have again in quadrant 1, so here's quadrant 1. What does this solid line look like? All right, well, if x is 0, y would have to be minus 6. If y is 0, then x has got to be 8. So I have x is 8, y is 0, so here we go, so right there. And I've got 0 minus 6, so here's the solid line. So again, we are in quadrant 1, and the question is, does this side work or this side? Well, I tried the point 1, 1. Let's see, 3 minus 4, plugging in 1 and 1, 3 minus 4 is minus 1, and is minus 1 greater than or equal to 24? No. Therefore, the opposite side works, and you notice this thing goes out this way forever, and so it is unbounded. All right, and in our last question here, the last question, we are given a series of inequalities, and they want us to figure out, well, where is it? All right, so first off, it is in the first quadrant. You do have to graph these lines, that's why they are in blue. If you don't graph them, then when you go to use your pouring tool or fill tool, it's going to bleed out everywhere onto the sides. So you must graph y equals 0 and x equals 0. Alright, so I have two lines. What do they look like? Well, they are solid lines because of the inequality. I then plug in x is 0, y is 6, y is 0, x is 3. So I've got 3, 0, and I've got 0, 6, and that's line 1. If I look at the second one here, x is 0, y is 3. Y is 0, x is 6. Alright, so here's line 2. Alright, so armed with all that, the question is, well, Out of all of this stuff, what do we shade? So I picked a test point living inside, which is 1, 1. So clearly 1, 1 is in the first quadrant, and 2 plus 1 is 3. That is less than or equal to 6. And 1 plus 3 again, less than or equal to 6. So this part does work. And so that's the part that is shaded. The second part of this, they say, what are all of these corner places? We're going to see in section 5.3 that the corner places are the most important because that's where you can maximize or minimize a condition. Well, 3 of these are easy. We can just read them from the graph. 0, 0, 0, 3, and this point 3, 0. Maybe if you zoom in, you could read this from the picture. Maybe it's easy, maybe it's not. The surest way is to solve our system of two equations and figure out where is that point. So to do that, I multiply the second equation by minus 2 because I want to eliminate the x. So add these up, they're gone. So I have minus 3y is 6 minus 12 minus 6. And I get that y is 2. And if you plug in y equals 2, you have x plus 4 is 6, and you get that x is 2. So the solution where the two lines intersect is at the point 2, 2, and that's where that corner point is. And from the graph, I can see that that is correct.